Good morning, student. Let's start today's class. In today's class, we are going to discuss about RC coupled transistor amplifier. In previous class, we have seen about the common emitter configuration, base voltage divider, biasing transistor. Okay. Now in RC coupled, okay, transistor amplifier, why this is called RC coupled transistor amplifier? It is usually employed for voltage amplification, remember this, and this figure shows two stages of RC coupled amplifier. Okay, this is the two stages of RC coupled amplifier. This is one stage, and this is the second stage. Okay, so there is two stages of RC coupled amplifier here, you see. Then a coupling capacitor CC, okay, used to connect the output of the first stage to the base or input of the second stage, and so on. Okay, so as the coupling from one stage to next stage is achieved by a coupling capacitor forwarded by a connection to a shunt resistor. Okay, shunt resistor means parallel resistor. Okay, um, therefore such amplifier is called resistance capacitance coupling amplifier. Okay, so you see here what happened. Since here the coupling means the connection between two stages, stage 1 and stage 2, is through one capacitor and these two resistors. Okay, the one capacitor and a short resistor which is R2, let's say R2. Okay, due to this capacitor and resistor, so that due to this region, this coupling is called capacitor RC coupled resistor, which is a resistor capacitor coupled amplifier. Okay, so RC coupled amplifier. Okay, here, and you know why we use RE. Okay, in previous classes we have already discussed was RE, R1, 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 R2, C in CE. Okay, remember this. Okay, now let us see what is the operation of this RC couple. Okay, in RC couple, whenever we applied, okay, let's say we applied signal, we get, whenever we applied, let's say this signal, okay, we get here in through the RC. Okay, a amplified, 1 minute, operation is that whenever we applied this. Okay, so at the time or after amplification of first stage, we get output in that RC. Okay, amplified signal. Okay, and again that amplified signal is given to the base of the next stage, and we get that here a big amplified signal. Okay, and so on. Then this then if the gain of this first stage is G1 and the second stage is G2, so total gain of this circuit is less than the product of the gain G1 and G2. Okay, because because it less than the product of the G1 and G2, because due to the this capacitor is parallel effect of R1. Okay, so the load, it is the RC is load for this first stage. Okay, and this RC is load for this stage. Okay, so whenever the load is affected by R1, okay, so load is reduced. Okay, so that the gain is reduced in G1, so that the multiplication of G1 and G2 is not similar to the total gain of that circuit. Okay, then now let us see. Okay, let us see the frequency response. Okay, the frequency response, and the figure 14 point, this is the frequency, response. Okay, now uh, now you see That shows the frequency response of a typical RC coupled amplifier. Okay, it is clear that voltage gain dropped off at a lower at lower frequency and high at voltage gain drops off at a lower less than 50 kilohertz frequency and high. Okay, and high is equal to or greater than 20 kilohertz frequency, whereas it is uniform over mid frequency range, which is 50 hertz to 20 hertz. Okay, so let's say this is frequency, this is 50 hertz, this is 20 hertz. So before 50 hertz or less than 50 hertz, this in this range of frequency the voltage gain is low. Okay, then after after or greater than the 20 hertz the voltage gain is high. Okay, then at low frequency less than 50 hertz, the resistance of coupling capacitor CC is quite high. Okay, since uh, the uh, resistance the resistance of coupling capacitor the resistance of coupling capacitor since the resistance of coupling capacitor is very high in low frequency, then a small part of signal will bypass from one stage to the next stage. Okay, moreover C is cannot shunt the emitter resistance Re effectively because of its large resistance at a lower frequency. Okay, these two factors can affect falling voltage gain of a lower frequency. That means in the lower frequency, since this CE is resistance is high. Okay, so there is a there is no low resistance path created. Okay, in previously we saw that this is the bypass capacitor. Okay, since there is a very high resistance created here due to the low frequency, so it became a high resistance path. So all the path, all the current IE current flowing in the RE through RE here. So here the drop is increased, so the gain the output voltage is also decreased. Okay, so that the gain is decreased. Okay, then whenever the high frequency here low resistance path created in high frequency here low resistance path created that means the resistance of and the resistance of emitter capacitor, okay, is less. So here a closed short circuit created so that it bypass the all current through it. Okay, the IE didn't go through the RE, so that 1 minute. So that whenever it is this capacitor act as a short circuit. Okay, so all the emitter current pass or high amplified current pass through this short circuit. Okay, not through this RE. Okay, so emitter current is not reducing. Okay, reduce. Okay, so gain is not reduced. Okay, so that the low frequency gain is low and high frequency gain is high. Okay, high frequency means after or greater than the 20 kilohertz, and low frequency means less than the 50 hertz. Okay, and in between them, in between 20 hertz and 50 hertz, okay, the the frequency the gain is stable. Okay, you see here you see before or below 50 hertz the frequency decreases. Okay, sorry, gain is decreases, voltage gain, this is voltage gain decreases, and in the 50 after 20 hertz or above 20 hertz the gain also decreases. Okay, so here in between the gain is constant. Okay, This is all about the frequency response of RC coupled amplifier. Okay, thank you.